Today we're going to take a look at object-oriented programming design, something that we don't always think about, but we still work through the procedure pretty regularly as we're programming. Think about the different things that go into making a cheeseburger. You have the bun, you have the meat, then you have the option of putting cheese on it and all the different condiments. What we're looking at with this is we're going to use building a cheeseburger as our example as we're working through the different OOP elements, which there are 5. The 5 steps in building or in the object-oriented programming model are identify the classes that need to be written, identify the behaviors for each class. We're going to have to take a look at what triggers behavior, determine the relationship between the classes, write the interface for each class, and then finally implement the method. So we're going to talk real briefly about all 5 of those. The first item is to identify the classes to be written. So build class relationships. So we're looking at what is related to what as we go and build this project. So when you think about a cheeseburger, the burger itself is related to all the different elements that are over here under the class, because it needs the bun, needs the meat, doesn't necessarily need the cheese or condiments, but most people usually get it with it. The trick with the class relationships is one class can give what it has to another class. When it does that, the one giving is actually called the parent class, and the one receiving is called the child class. So that talks about a parent-child relationship. And the easy way to remember which is think about when you were growing up, whether you had a parent or guardian. For this example, use a parent. You got everything that the parent got because they were taking care of you. So you had your parents' TV, you had what your parents bought at the grocery store, you had pretty much everything that your parents bought, but then you also got your own stuff that they didn't use. They didn't take your toys, I would hope, or if they bought you something for Christmas, then it was exclusively yours. We're disregarding sharing with a sibling for this example. But you still got everything that your parents gave you, so the child can take everything that the parent gives them, but the parent does not take anything from the child. Identify behaviors for each class. So, what we're looking at when we're talking about the behaviors is we're looking at the functionality of each class. What do we want to know about each class? And when we're looking at this, we're looking for verbs. So verb words or phrases that want to have happen with each class become the name eventually of our methods. Verbs, and once in a while I think an adverb or adjective, but it's traditionally like verbs, because if you're talking about a noun, then you usually put the word get in front or something of that sort, which we'll see here in a second. On this chart, I went ahead and broke down the behaviors for each of the classes within our program here. So the class names are the 5 things still on top: bun, meat, cheese, condiments, and burger. But then we start to look at, if we were talking about the bun, for example, we want to know, okay, do we have buns in stock? So there's the checking the description, are they in stock? Is the bun toasted? Is it moldy? And then get the type of bun that we want, which would kind of throw off the in stock method a little bit, but that's okay. Same with the meat. Is our meat cooked? Is it spoiled? Is it in patty form? Did we get ground beef and is it in patty form? All the way down to burger, are we able to make it? We have to assemble it, and then we have to deliver the burger as well. So those are a couple things that we have to do with the burger. Cheese and condiments, more or less down the same line. I could have gone on all day with the condiments. Once ketchup, once pickles, in stock. The cheese is pretty similar to the bun and the meat. Kind of took a little bit from both. The next piece is we need to determine relationships between each class. And this is where, if you're thinking about it, you're probably going to get hicked up a little bit, because we know that the burger, I've been watching too much Jimmy Neutron, the burger needs, at least to be classified as a burger, it needs bun and meat. So it needs those two things. It doesn't necessarily need cheese or condiments to still be classified as a burger. So we're talking about, how do each of these classes rely on each other? And all classes should rely on at least something to reach the final product. If we're making a program with multiple classes like we are here, something has to rely on something for an object to exist. So for this, we look at the two types of relationships that we can have. We can have an inheritance relationship, which is an is-a relationship. You is a part of your parents. I know it's not grammatically correct, but that's the kind of description we're going for here. We need our parents for us to exist. Not to be confused with a composition relationship, which is a has-a relationship. A nurse has a uniform. A student has a grade. A cheeseburger not necessarily is a piece of cheese, but it can have a piece of cheese. So with this, we're going to use what are called the UML symbols and rules. UML stands for Uniform Modeling Language. And if you look on their website, the guide is enormous. But for our purposes and for AP purposes, we're only going to see this in talking about class structure. So we have essentially 5 different ways we can use the symbols. The regular rectangle without anything below it represents a standalone class in our program that we would use. So each of our 5 things right now, the burger, cheese, meat, condiments, and bun, are all classes. When we get into building abstract and interface classes, if our class is that, then we simply have to go underneath the class name and add the word interface or abstract inside the angle brackets, which I nickname tags. This is where it gets tricky. If we want to show an is-a relationship between classes, then we use an open up arrow. So that means that the triangle is hollow and the arrow is pointing up, which you'll see on the next slide when I build our relationship here. If we're doing that with an interface or an abstract, or just an interface, it's just an interface, then it's dotted lines and an open arrow. So I do not have an example of that, but know that that would be on the very top. And then the has-a relationship is a down arrow or sideways arrow, dark and colored in. So with our burger example, I went ahead and concluded that we need a bun and meat for our burger to be a burger. But we don't necessarily need cheese or condiments for a burger to still be classified as a burger. It just tastes better. So we have an is-a relationship with our bun and meat, so it's the arrows pointing up, but we have a has-a relationship with the cheese and the condiments because we don't necessarily need them. The next step is to write the interface for each class, which we haven't got to yet. But essentially what we're looking at here is we're looking at 2 different ways to build it out. We can either build from the bottom up, which means that we're looking at each individual class, building it out as it is, and then combining them together. So we test each class separately, then combine them together. Or the top down, where you focus on the main part you're trying to get to, and then as you're going along, you build out the class. I gave you an example of if our inner buns would have been interface. Then this is kind of what it looks like. So an interface is essentially nothing more then a bunch of methods listed out without the actual code. It's just kind of a planning phase. But then when you build an interface, it helps you execute the code better, which we'll take a look at when we get there. And the final slide here is to implement the methods. And with implementing, we have 4 different things we're kind of looking at. We're looking at procedural abstraction. What this allows us to do is, as we're building out our code, we want to, 1, avoid repeated code. But 2, we also want to break down larger pieces of code into smaller methods because 1, we may need that portion somewhere else, and 2, we want to make sure that we're keeping our program as small as possible so that we take up less memory. We also have to look at information hiding, which I always use the example of the bank account. You don't want your bank account being a public variable, for example, because then everyone be able to access and change their bank account, and then money becomes useless. So this is when we're talking about declaring private variables and methods. Private methods are also called helper methods because they access hidden information that you don't want to get to, but then make it so that you can still somehow work with it in a public context. Stub methods are probably what we'll use the most off this list. It's a method that fills in for a method, not wrote or implemented yet, so we haven't wrote the method yet, but it's used to test the program's functionality. So essentially it's like, I'm going to build this, I'm going to have this right now, call to it and have it run, but it's not done. That's a stub method. And the final piece is the algorithm. And the book simply said, don't write any code for an algorithm until you understand the steps, which I think is very important. Because if you're writing an algorithm and you have no clue what you're doing, it's not going to work out.